So for our problem, we had the natural log of x squared minus 16, and when you want to take the first derivative of it, it's always 1 over x for a natural log. So your first derivative is going to end up being 1 over x squared minus 16 times the derivative of your inside function, which is going to be 2x. And now this is going to simplify out to being 1 over x squared minus 16 times 2x over 1, and you're just going to cross multiply it. It's going to end up being this, 2x over x squared minus 16. And this function is going to show where it's increasing or decreasing. For the second derivative, you're going to want to do the quotient rule. So it's low d high minus high d low all over square low. So that's going to end up being x squared minus 16 times 2 minus 2x times 2x all over x squared minus 16 squared. And if you simplify that out, multiply everything out, it's going to end up being 2x squared minus 32 minus 4x squared all over x squared minus 16 squared. Now you're going to want to set this equal to 0, and when you do that, you end up getting inflection points of 4 and negative 4. And these inflection points basically show you where your graph is changing direction. So as you can see, negative 4 is shown right here on the graph, and 4 is shown right here on the second derivative graph. Now also on this graph, anywhere where your second derivative graph is below the x-axis in this area, that means that it's decreasing. And anywhere where it's above the x-axis, as in right here and right there, that means it's increasing from those intervals. So say you wanted to find out where it was, it would be increasing from negative infinity to negative 4 and as well 4 to infinity. And it would be decreasing from negative 4 to 4 if you wanted to write that in interval notation. And that's about it. Thanks a lot.